Hello everyone, welcome to Edupedia World Videos. In our today's lecture, we will discuss electronic configuration of elements and periodic trends in atomic properties. First, we will discuss electronic configuration of elements. The properties of elements depend on their electronic configuration. The electronic configuration of elements changes both in a group and in a period. First, we will discuss down a group. On moving down a group from top to bottom, there occurs successive increase of number of electron orbits by 1. So in group 1 elements, lithium has 2 orbits of electrons, sodium has 3 orbits of electrons, that is KLM shells, and potassium has 4 orbits of electrons, KLMN shells, and so on. The number of valence electrons in all group 1 elements is the same. The chemical properties of elements depend upon the number of valence electrons. The elements having the same number of valence electrons exhibit similar properties. Since the valence electrons in the consecutive elements in a group are repeated after certain interval of atomic numbers, the properties of the elements in a group repeat periodically over the regular sequence of repetition of atomic numbers. The number of valence electrons determines the valency of an element. It is due to this reason that the outermost shell is also called valence shell. Valency of representative elements is either equal to the number of valence electrons or 8 minus the number of valence electrons. All the group 1 elements have 1 valence electrons and all the group 1 elements exhibit similarity in chemical properties. The elements of the same group exhibit same valency in their compounds. Now along a period. On moving from left to right along a period, the number of valence electrons in the elements increases from 1 to 8. Except in the first period where the number of valence electrons increases from 1 to 2. The first element in every period has only 1 valence electrons and the last element in every period has 8 valence electrons. On moving from left to right along a period, the electrons are added to the same orbit. Thus, in the second period, the electrons are added to the second orbit, that is K shell, and in the third period, the electrons are added in the third orbit, that is M shell. As one moves from left to right in each short period, the valency of elements increases from 1 to 4 and then decreases to 0 in the last elements of the period. This change in valency in a period leads to change in the nature of compounds. Now, atomic radius. These are all atomic properties. The physical characteristics of the atom of an element are called atomic properties. The physical properties such as melting point, boiling point, atomic radius, ionization energy, electron affinity, electron negativity, valency, density, etc. are atomic properties. Now we will discuss periodic trends in atomic properties. The properties of elements exhibit a regular variation in the groups and periods of the periodic table. The various properties of elements which change on moving down in a group or across a period of the periodic table. A thorough knowledge of the trends in the properties of elements not only helps us to understand the properties of elements but also to predict the method of preparation and properties of yet to be discovered elements. It is impossible to study separately 117 elements. But it is rather easier to study the trends in properties of these elements. First is atomic radius. What is atomic radius? It is the distance from the center of the nucleus to the outermost shell of the electrons in an atom is called atomic radius. Atomic radii of diatomic molecules are obtained from bond lengths of diatomic molecules. The direct measurement of atomic radius does not provide an accurate value since the electrons do not move around a nucleus at a fixed distance from the nucleus. Variation of atomic radius in a group. The atomic radii of elements increases with increase in atomic number on moving from top to down in a group. On moving down a group, a new shell of electrons is added at each succeeding element. Hence, the electrons in the valence shell of each succeeding element lie further and further away from the nucleus. Consequently, the attraction of the nucleus for the electrons decreases, and as a result, the atomic radius increases with increase in atomic number. But the nuclear charge of elements also increases. This produces a contractive effect on the atomic radius. The increase in atomic radius due to the addition of new shell is so large that it overweighs the contractive effect of the increased nuclear charge. And as a result, the atomic radius increases on moving down a group from top to bottom. Variation of atomic radius in a period. The atomic radii of elements decreases with increase in atomic number on moving from left to right in a period. On moving left to right along a period, the nuclear charge increases by 1 unit in each succeeding element while the added electron enters the same shell. As a result, the electrons of all the shells are strongly pulled towards the nucleus. So there is a steady contraction in atomic radius from left to right in a period. Now, electropositive or metallic character. The tendency of an element to lose electrons and form positive ions, which is cations, is called electropositive character. Since metals exhibit such a tendency, the electropositive character is also known as metallic character. Hence, metals are electropositive in nature. Metals tend to form bonds by losing electrons. The metals are characterized by ductility, malleability, and electrical conductivity. And the tendency of a non-metal to gain electrons and form negative ion, that is anion, is called electronegative characters. Hence, non-metals are electronegative in nature. Non-metals tend to form bonds by gaining electrons. The non-metals are generally gases or brittle solids and are conductors of electricity. The trends in electropositive and electronegative character of elements are useful to predict the nature of oxides formed by the elements, since generally the metal oxides are basic and the non-metal oxides are acidic. Variation of metallic and non-metallic character in a group. On moving down a group, the metallic character of elements increases. This is due to the increase in atomic radius on moving down the group. Since the distance between the nucleus and the outermost electrons increases on moving down a group, the force of attraction between nucleus and electron decreases and less energy is required to lose electrons. Variation of metallic and non-metallic character in a period. On moving from left to right in a period, the metallic character decreases and non-metallic character increases. Relation between metallic character and reactivity. The reactivity of metals increases with increase in metallic or electropositive character. On the other hand, the reactivity of non-metals increases with increase in electronegative character. Thus, the greater the electropositive or electronegative character of an element, the greater is its reactivity. Ionization energy. In an atom, the electrons are held by electrostatic force of attraction to the positively charged nucleus. In order to remove an electron from an atom, energy must be supplied. The amount of energy required to remove the most loosely held electron from an isolated gaseous atom is called ionization energy. A quantitative measure of the tendency of an element to lose electron is given by the ionization energy, and its unit is kilojoule per mole. Ionization energy is always endothermic and thus is always assigned a positive value. The energy required to remove the first electron from an isolated gaseous atom is called first ionization energy. There are various factors which affect ionization energy. They are atomic radius and nuclear charge. Ionization energy decreases as the atomic radius increases. The attraction of nucleus on the outer electrons decreases as the distance of the outer electrons from the nucleus increases. So the outer electrons are held less firmly and lesser amount of energy is required to remove them. Second is nuclear charge. Greater the nuclear charge, greater is the electrostatic force of attraction between the nucleus and the electrons, and greater is the ionization energy. So ionization energy increases with increase in the nuclear charge. Variation of ionization energy in a group. On moving down a group, the ionization energy of elements decreases with increase in atomic number. On moving down a group, the atomic radius increases due to the addition of new electron shell at each succeeding element. On moving down a group, the nuclear charge increases with increase in atomic number. Hence, the electrostatic force of attraction between the nucleus and electrons increases, and accordingly the ionization energy should increase. But the effect of increase in the atomic radius more than compensates the effect of the increased nuclear charge in increasing the ionization energy. Hence, the ionization energy decreases on moving down a group. Variation of ionization energy in a period. In any period in the periodic table, the ionization energies of elements increases from left to right, being smallest for the alkali metal atoms and largest for the noble gas atoms. This is due to the combined effect of the increased nuclear charge and decrease of atomic radius with increase in atomic number. Now, electron affinity. Just as energy is required to remove an electron from an isolated gaseous atom, energy is released when an electron is added to an isolated gaseous atom. This energy is called electron affinity. Electron affinity of an element is the energy released when an isolated gaseous atom accepts an electron to form the gaseous negative ion. Thus, a quantitative measure of the tendency of element to gain electrons is given by the electron affinity. Electron affinity is expressed in the unit of kilojoule per mole. Larger the amount of energy released during the addition of an electron to an isolated gaseous atom, greater is the electron affinity of the element. Since more energy is released during the addition of an electron to an isolated gaseous atom, there are factors which affect electron affinity. They are atomic radius and nuclear charge. Atomic radius. Electron affinity decreases as the atomic radius increases. With increase of distance between nucleus and the last electron shell which receives the added electron, the electrostatic force of attraction between the nucleus and the added electron decreases. Hence, electron affinity decreases with increase in atomic radius. Nuclear charge. Greater the nuclear charge, greater is the electrostatic force of attraction between the nucleus and the added electron, and greater is the electron affinity. Thus, electron affinity increases with increase in nuclear charge. Variation of electron affinity in a group. The electron affinity of elements decreases on moving down a group. There is some exception. Electron affinity of nitrogen, oxygen and fluorine second period are lower than those of phosphorus, sulfur and chlorine third period. Variation of electron affinity in a period. The electron affinity of elements increases on moving from left to right in a period, but not in a graded manner. On moving in a period from left to right, the atomic radius decreases and nuclear charge increases. Both these factors increase the attraction of added electron by the nucleus. Hence, electron affinity decreases in a period from left to right. Now, electronegativity. Electron affinity is a measure of the tendency of isolated gaseous atom to accept an electron. The concept of electron affinity is not applicable to an atom in a compound. Electronegativity of an element is the tendency of an atom in a molecule to attract a shared pair of electrons towards itself. The electronegativity value of an element denotes the ability of its atom to compete for the shared pair of electrons with another atom to which it is bonded. Electronegativity is a number and it does not have a unit. Variation of electronegativity in a period. Electronegativity increases in a period on moving from left to right. On moving from left to right in a period, the atomic radius decreases and the nuclear charge increases. Due to the combined effect of decreasing atomic radius and increasing nuclear charge, the shared pair of electrons is more strongly attracted towards the nucleus. As a result, the electronegativity increases in a period from left to right. Difference between electronegativity and electroaffinity. Although both electron affinity and electronegativity are the properties of attracting electron towards the atom, electron affinity refers to the electron attracting property of an isolated gaseous atom, and electronegativity refers to the electron attracting property of a bonded atom in a molecule. Electron affinity has a unit, but electronegativity is a number and does not have a unit. Electron affinity is an absolute value, but electronegativity is a relative value. These are the basic differences between electron affinity and electronegativity. This is the summary of periodic trends in the periodic properties, in which we can see that electron affinity is increasing and atomic radius is decreasing. This is the summary of trends in the periodic property of elements in the periodic table. Thank you for watching Edupedia World videos.